Hello, welcome all. Today we'll be discussing about the topologies in the computer networks. Topologies can be considered as the backbone of the computer networks. So we'll start with what is a topology. Topology defines the structure in which computers are connected to each other. It indicates the flow of data in the network, and the selection of the topology is based on the size, the data rate, and the requirements of the client. So what are the main types of topologies which we use in the network? Main types of topologies which are used in the network are bus, star, ring, and mesh topology. We'll start with bus topology. Bus, as the name suggests, it gets its name from the linear flow of data in the network. The nodes are connected together by a backbone cable, which is also called as the trunk cable. That is a single line which connects all the computers together. The data flow is in, and the computers are placed in the linear structure. That is why it is called as bus topology. Next, we will be discussing how communication takes place in the bus topology. Computers on a bus topology network communicate by addressing data to a particular computer and sending out the data on the cable as electronic signals. And when the signal is transferred on the data, all the nodes in the network receive the data, and the one which is the receiver accepts the data and others reject the data. So there's three further stages in the network: sending the signal, signal bounces, and why we use terminators in the bus topology. In the upcoming slides, we will discuss these. See, this is bus topology in which all the nodes are connected using a backbone cable, which is also called as trunk cable. How data is sent in the bus topology. Network data is sent in the form of electronic signals to all the computers on the network, and only the computer whose address matches the address encoded in the original signal accepts the information, and all other computers reject the data. So data is sent to all the computer, but only the receiver or the destination computer accepts the data, others reject it. This example shows the addresses used in the bus topology. These are the hardware or MAC addresses shown in the topology. All the computers, let us say in this example, if 8B is sending the data, all the nodes will receive the data, and 8B has sent the data to 5.6. Only 5.6 will receive the data, accept the data, others will reject it. But there are some performance issues in bus topology. For example, congestion. Because only one computer at a time can send data, rest of the computers will have to wait to send the data. There are also speed delays in the network. There is no standard way to measure the impact of a given number of computers on the speed of any given network. Neither it is solely on the basis of the number of computers only. There are other hard factors as well. For example, the hardware capabilities of the computers, the total number of queued commands which need to be executed, types of cables, types of applications, etc. All these factors combined in totality affect the performance of the nodes in bus topology. Some other issues connected with bus topology are bouncing of signals. Because data or electronic signal is sent to the entire network, it travels from one end of the cable to the other. And if the signal is allowed to continue uninterrupted, it will keep bouncing back and forth in the cable, which will stop other computers from sending the data. So what is the solution? The solution is using a terminator. To stop the signal from bouncing, a component called a terminator is placed at each end of the cable to assure the free signal is absorbed. It won't continue to bounce back and forth on the cable. So both ends of the each cable segment onto the network must be plugged into something. For example, a cable end can be plugged into a computer or a connector to extend the length, and any open cable ends will be connected to the terminator to prevent bouncing of the signal. See, in this case, This example shows here how terminator is connected to end the signal. Ideally, it will be connected to this, let us say this is first, second, third, and fourth. Ideally, it will be connected to this fourth PC. Some other disadvantages is the disrupting of the network communication. If this backbone cable breaks in the bus topology, whole of the network will go down. The computers on the network still will be able to function as standalone computers, but they won't be able to function as a network together. Yes, if it happens that if two of the pieces are on the one side, now let us say in this first and second on the one side, they will be able to communicate with each other. But this third one, where the backbone cable has broken, they won't be able to communicate with each other. Another issue is network expansion. As the physical size of the site grows, the network will need to grow as well. Cable in the bus topology can be extended by one of the following methods. First method is using a barrel connector, which connects two pieces of cable together to make it a longer piece of cable. I can show you here what is BNC barrel connector. This is BNC barrel connector, which is used to connect two cables to make them longer. Another method is using repeaters, which is more popularly used because repeaters actually boost the signal before it is transferred on the cable. So if there is any weakening of signal, repeaters corrects that also. As you can see, here the signal is slightly weakened, but by using the repeater, it is regenerated. Next is star topology. In star topology, the cable segments from each computer are connected to a centralized component which is called a hub. This is adaptation of a client server architecture where server used to be in the middle and clients used to be connected together to the server. So in this case of star topology, all the nodes are connected to the central device hub. The star network offers the advantage of centralized resources and management. It is very easy to troubleshoot also in the star topology. All the PCs which are connected to the hub, they have the lights indicated on the ports. As soon as the light goes down, it turns to amber color and it can be easily detected which node is a failure and it can be troubleshooted. If one computer or the cable that connects to the hub fails on a star network, whole of the network is not disrupted. Rest of the network continues to function properly. There won't be any issue in the network. Next is ring topology. Ring topology connects the computers on a single circle of a cable. They get the name from the circle because of the movement of the token in the network. Usually, a token is circulated in a unidirection, in one direction, and passes through each computer, which acts as a repeater to boost the signal. In this example, you can see there will be a token which will be circulating in all these pieces together. So using token passing, a PC who wants to transfer the data will attach its data to the token. What is a token? Token is a special series of bits that travel around a tokening network. And each network has only one token. So as you can see, if each network has one token, it is totally collision free. There are no chances of any collision in the network. The sender computer who wants to send the data takes the token, accepts the token, attaches some of its electronic address on the data and sends it around the ring, and the destination address will receive the token, get the message, and then pass it back to the sender, and sender will receive it as an acknowledgement, and the acknowledgement is received, and once again the token is circulated freely in the network for any other node to pick and transfer the data ahead. See, in this example, you can see the token is transferred between the nodes and one data can transfer the data using only the token. The data passes by each computer until it finds the address where the destination address matches. The receiving computer returns a message to the sending computer indicating that data has been received. So this acts also as an acknowledgement, the verification that yes, the data has been received. It might seem that the token passing would take a long time, but on the contrary, a token can circle a ring 200 meters in diameter about 477,376 times per second. That is pretty fast. Next, we are going to discuss is the mesh topology. Mesh, as you can think of the net or a web, it gets its name from the interconnection of the wires which make it looks like a feeling of a web or a net, and that is why it is called as mesh topology. In mesh topology, each computer is connected to every other computer by a separate cable. So if one cable goes down, you have another way of going to that PC. This configuration provides redundant paths to the network so that if one cable fails, another will take over the traffic. While ease of troubleshooting and increased reliability are definitely pluses, these networks are expensive to install because they use a lot of cabling. Often a mesh topology will be used in combination with other topologies, giving rise to the term hybrid topologies. In practicality, in actual life, if you see, hybrid topologies are implemented. We are never going straight only for one topology because most of the time the client's requirements can only be fulfilled by using hybrid topologies. For example, star bus, which is a combination of bus and star topology. In star bus topology, several star topology networks are linked together with one linear bus trunks. If one computer goes down, it will not affect the rest of the network. Others can continue to work together. And if a hub goes down, all computers on that hub are unable to communicate while the others can continue to operate. See, this is an example. This example, there is a star connection, topology connection between the PCs and a hub, and the hubs are connected using bus topology. So this is an example of star bus topology. Similarly, we can have the star ring topology. The nodes are connected to the hub using the star topology, and all the hubs are interconnected using a ring topology. It's not necessary that we have to place those pieces or devices which we are going to connect using the ring topology in a circle. The name is driven from the flow of the data in the network. The flow of the data in the ring topology using a token in a unidirectional way is via ring topology. So what are the advantages and disadvantages of these topologies? In bus topology, use of cable is economical. It's very cheap, not at all expensive. Easy to install. System is simple and reliable. It's very easy to extend. You can add repeaters and extend the nodes as many as you want. And in the disadvantages, network can slow down when we have too many PCs in the network. Problems are very difficult to isolate, and a break in the backbone cable can affect many users in the network. In ring topology, it provides equal access for all computers. Performance is even despite many users. Failure of one computer can impact the rest of the network. Problems are hard to isolate. It's difficult to troubleshoot in case of ring topology. And if we have to reconfigure the network, whole of the network operation is disrupted. If, for example, if any changes have to be made in case of the token bits, whole of the network will go down. Nobody can transfer the data. The advantages of star topology: centralized management and monitoring. Troubleshooting is easiest in this. Failure of one computer does not affect rest of the network. But the main disadvantage, if the centralized point, that is your hub, if it fails, whole of the network goes down. So what are the advantages of mesh topology? It provides redundancy and reliability. No matter the number of failures, your network will you are assured to have assured delivery. And disadvantages: system is expensive to install because it requires lots and lots of cables. So this finishes off with the topology's introduction in the networks. Please subscribe my channel to have more networking videos. Thanks for watching.